Our planet Earth, a magnificent blue sphere teeming with life. But have you ever wondered how this oasis in space came to be? It's a tale of cosmic collisions, fiery upheavals, and the march of life. The solar system was a swirling cloud of dust and gas. Gravity drew these particles into a spinning disk. At the center, the sun ignited, bathing the disk in light and heat. Smaller clumps began to coalesce, forming planets. One clump became our home, Earth. Collisions with asteroids and comets were common. The young Earth was a molten ball bombarded from space. The first eon in Earth's history, spanning from 4.54 billion to 4 billion years ago, is aptly named the Hadean. This period was characterized by extreme heat, volcanic activity, and constant asteroid impacts. The surface was a molten sea, with volcanic eruptions spewing lava and gases. The air was thick with carbon dioxide, nitrogen, and water vapor. It was a hostile alien environment.
One significant event was the formation of the Moon. A Mars-sized object collided with Earth, blasting debris into space. This debris coalesced to form the Moon.
Towards the end of the Hadean, Earth cooled, forming a solid crust. Water vapor condensed and fell as rain, forming the first oceans. The stage was set for the emergence of life. As the Earth cooled and stabilized, life found a foothold. The Archean Eon, stretching from 4 billion to 2.5 billion years ago, witnessed the emergence of the first single-celled organisms. The exact details of how life arose from non-living matter remain a mystery, but it is thought to have occurred in the early oceans. These primordial seas, rich in dissolved minerals and organic molecules, provided the necessary ingredients and conditions for life to spark. The earliest life forms were simple, single-celled prokaryotes, similar to bacteria. They were anaerobic, meaning they didn't need oxygen to survive. In fact, oxygen was toxic to these early life forms. Their energy came from chemosynthesis, a process of converting chemicals into energy.
Around 3.5 billion years ago, a new type of organism emerged, cyanobacteria. These microscopic creatures possess the remarkable ability to photosynthesize, using sunlight to convert carbon dioxide and water into energy and releasing oxygen as a byproduct.
The Proterozoic Eon, spanning from 2.5 billion to 541 million years ago, was a time of profound change. The oxygen released by cyanobacteria began to accumulate in the atmosphere, leading to the Great Oxidation Event. This event was a turning point in Earth's history. Oxygen was toxic to many anaerobic life forms, and the Great Oxidation Event led to a mass extinction. However, it also paved the way for the evolution of new life forms that could utilize oxygen for respiration.
Another significant event of the Proterozoic Eon was the formation of the first eukaryotic cells. These cells were more complex than prokaryotes, with a distinct nucleus containing their DNA. Eukaryotes would eventually evolve into all plants and animals we see today.
The Proterozoic also witnessed several periods of extreme glaciation, known as snowball Earth events. During these periods, glaciers covered much of the planet, reflecting sunlight back into space and further cooling the Earth. The causes of these glaciations are still debated, but they highlight the dynamic nature of Earth's climate throughout its history. Section 5. The Cambrian Explosion, Life's Big Bang. The Phanerozoic Eon, which began 541 million years ago and continues to this day, is marked by the proliferation of complex, multicellular life. The first era of the Phanerozoic, the Paleozoic era, began with a dramatic event known as the Cambrian Explosion. Over a relatively short period, perhaps as little as 20 million years, the fossil record shows an explosion of diversity in marine life. New body plans evolved, leading to a wide array of creatures, from trilobites with their hard exoskeletons to the first predators with grasping appendages. The Cambrian explosion was a pivotal event in the history of life. It established the basic body plans for most major animal groups that exist today and set the stage for the diversification of life on Earth. The Paleozoic era continued with the Ordovician, Silurian, and Devonian periods. These periods saw the rise of fish, the first land plants, and the colonization of land by arthropods, eventually leading to the evolution of insects. Section 6. The Paleozoic era, from sea to land. The latter half of the Paleozoic era, comprising the Carboniferous and Permian periods, witnessed the greening of the land and the rise of reptiles. During the Carboniferous period, vast forests of ferns and giant trees covered the land. These forests were home to a diverse array of insects, amphibians, and early reptiles. The decomposition of this plant matter over millions of years led to the formation of the coal deposits that we rely on today for energy. The Permian period saw the continents collide to form the supercontinent Pangaea. The climate became drier, leading to the decline of amphibians and the rise of reptiles, who were better adapted to drier conditions. The Permian period ended with the largest mass extinction event in Earth's history, wiping out over 90% of marine species and 70% of terrestrial species. Section 7, the Mesozoic era, the age of reptiles. The Mesozoic era, spanning from 252 to 66 million years ago, is often called the age of reptiles. This era saw the rise and fall of the dinosaurs.
The Triassic period saw the emergence of dinosaurs. They quickly diversified and spread across Pangaea, becoming the dominant land animals.
The Jurassic period was the heyday of the dinosaurs. Giant sauropods roamed the Earth while predatory theropods stalked their prey. The Cretaceous period saw the continued dominance of dinosaurs and the emergence of flowering plants. However, it ended with a mass extinction event triggered by an asteroid impact.
Section 8. The Cenozoic era, the age of mammals. The Cenozoic era, which began 66 million years ago and continues to this day, is known as the age of mammals. With the dinosaurs gone, mammals diversified and filled the ecological niches left vacant.
The Cenozoic is divided into three periods: the Paleogene, Neogene, and Quaternary. During the Paleogene, mammals evolved rapidly, giving rise to the ancestors of modern-day hoofed mammals, primates, and whales.
The Neogene period saw the continued evolution of mammals, with grasslands expanding and favoring the evolution of grazing animals. The first hominids, our early human ancestors, appeared in Africa during the late Neogene.
The Quaternary period, which began 2.6 million years ago, has been marked by a series of ice ages interspersed with warmer interglacial periods. The Quaternary also witnessed the evolution of modern humans, Homo sapiens, and our spread across the globe. Section 9. The Rise of Humans, a new chapter in Earth's story. The rise of humans is a relatively recent event in Earth's long history, but it has had a profound impact on the planet. From our humble beginnings in Africa, humans have spread across the globe, altering landscapes, domesticating plants and animals, and developing complex societies. Our species, Homo sapiens, evolved in Africa around 300,000 years ago. We possessed larger brains and greater cognitive abilities than our hominid predecessors, allowing us to develop language, tools, and complex social structures. As humans migrated out of Africa, we encountered and interacted with other hominid species such as Neanderthals and Denisovans. While these archaic human groups eventually disappeared, they left behind traces in our DNA, a testament to our shared ancestry. Section 10. The Anthropocene Humanities Footprint. The impact of humans on the planet has become so significant that scientists have proposed a new geological epoch, the Anthropocene, to mark our influence. The Anthropocene is characterized by human-induced changes to the Earth's systems, including the climate, biodiversity, and the nitrogen cycle. The Industrial Revolution, which began in the 18th century, marked a turning point in human history and our relationship with the planet. The burning of fossil fuels, deforestation, and industrial agriculture have led to a dramatic increase in greenhouse gas emissions, altering the Earth's climate at an unprecedented rate. Human activities have also led to a decline in biodiversity, with many species facing extinction due to habitat loss, pollution, and climate change. The Anthropocene is a stark reminder of our responsibility to manage our impact on the planet and ensure a sustainable future for all life on Earth. Section 11. A continuous cycle reflecting on Earth's epic journey. As we reflect on the epic history of Earth, from its fiery birth to the present day, one theme emerges: change is the only constant. Our planet has experienced periods of intense heat and cold, dramatic shifts in atmospheric composition, and the rise and fall of countless species. Life itself has shown remarkable resilience, adapting to changing conditions and diversifying into a breathtaking array of forms. From the simplest single-celled organisms to the complexity of the human brain, life has found a way to thrive in even the most challenging environments. As we face the challenges of the Anthropocene, it is important to remember that we are part of this ongoing story. The choices we make today will shape the future of our planet and the life it supports. By understanding our place in Earth's long history, we can gain a deeper appreciation for the preciousness of life and the importance of safeguarding our planet for future generations.